Hi, this is Sharia for Spark Week 3 update. What I've been working on is plant decellularization for tissue engineering scaffolds. And what that is basically is removal of all organic material from a tissue. So we've been testing out different plants for different geometries. My batch 1 was spinach, parsley, and kale. And to the left is a decellularized and bleached version of the kale. And then my batch 2 was cabbage, apple, and cherry, which here are the pictures from last week. So we're trying to make the most efficient process of decellularization and then the most durable plant or like scaffold that we can find. So this is present day. Not a lot has happened, but I've been trying to dry out the cabbage here, and as you can see, like half of the upper part is fully clear for the cherries, but the apples is not like the same case. Apples are like basically looks the same. So I've been trying to put it in another SDS solution here, and hopefully that makes decellularization much faster. So the main thing we did this week is that we visited Antec, the Northwestern facility, which stands for Analytical Bionanotechnology, and we met a few professors, namely Hiroaki Sai and Nozumo Takata. And Hiroaki Sai is like the material scientist, helping out Nozumo Takata with his research on organ growth and repair in central nervous system, and he's specifically focusing on spinal cord injury, which is harder to fix than, for example, like skin cut. And he's using human stem cells to grow organoid models that, if successful, will help with regeneration of tissue and organ, and specifically mitigate the effects of spinal cord injury. So he also taught us like the basic way to create an organoid, which I can show here is first you need a human stem cell, and then you'll put it in a mineral soup which has all the chemicals needed for the human stem cells to grow over time. And then you need to put it in like a petri dish and in a container for it to continue growing. And that then you would get like a final organoid which kind of looks like this. But it depends on the specific organoid you're trying to grow. For example, he showed us an organoid of brainstem, and that's specific to the spinal cord injury. But it looks slightly different than this, but like almost the same color and like the same shape. And this is the same like process, like a basic process of going through on how to make an organoid. So the main relevance to what we learned there is that he's also working on regenerative medicine. It's just like a different process to go about regenerative medicine. And they also have a lot of equipment in Antec, and we'll be get to using some of them. Not like all of these, but the main ones we're probably going to use is like the lyophilizer, which is like the dry freeze machine, and then probably the plasma cleaner to make sure the scaffolds are fully clean and ready to be used after. And that's it for my update for this week. Thank you.